Alright, welcome to the 3C video. So on 3C, we are simplifying negative radicals containing negative numbers, so the square roots predominantly, or that's what we're doing for this. So I have to think about perfect squares, so always think about perfect squares. So 2 squared, 3 squared, 4 squared, 5 squared, 8 squared, 9 squared, and 10 squared. Those are the main numbers I would think about. You could do 11 or 12 or 13 squared. So 4, 9, 16, 25, 36. And I'm going to be doing this for every single problem, thinking about these. Whoa. 81 and 100. So I need to think about the square root of negative 18. I just think about 18. So we're going to break this down. The negative is going to be the 1. 18, is that divisible by 4? No. 18 divided by 9? Yes. Is 18 divided by 16? No. And I don't have to go any higher. So divide by 9. So it's 9 times 2 is 18. Now let's break this down a little further. The square root of negative 1 and the square root of 9 and times the square root of 2. Square root of negative 1 is I, square root of 9 is 3, and then we don't know what the square root of 2 is. I'm going to rewrite this, and that's going to be my final answer. 3 times I, or 3I, square root of 2. Number 16. So this is a multiplication on the outside, 6 times. I'm going to look at what's underneath the square root. We have the square root of negative 1. 56. Does 56 divide by 4? Yes, it does. Does 56 divide by, let's see here, 56 divided by 4, what is that, 14? 4 times 14. You can look at what, so if I take the perfect square, or the square root of 4, that's 2. Square root of 14, there is not a perfect square that I can divide out of that. So that tells me 4 and 14 are for square root of 4 is the biggest perfect square. Like 56 doesn't divide by 9, 56 won't divide by 16. 56 won't divide by 25, and that's about halfway to 56 is 25, so I don't have to go any bigger than that. So I have 4 and 14, and then I'll talk about the variables in a little bit. So when we break this up, we have an I times 2, and then we still have the square root of 14, x to the 7th, y to the 8th. Now when it comes to x, so we have 7 x's multiplied together, and it's a square root, so we think about like pairs. How many groups can you take out of 7? Well, there should be 3. So I'm going to rewrite this as 2i. There's x to the 3rd, and then there is an x left over underneath the radical. Of the 7, you can take 3 groups, which will be 6 total x's, and there'll be 1 left over. Oh, 1 left over, not 7. So it's just x or x to the 1st, but really don't need that first. And then y to the 8th, there's 8 y's multiplied together. How many groups can you take out? 2 groups of 2. That'd be 4. There's none left over, so there's no more y's underneath the radical. This is your final answer. All right, number 17 kind of makes us think. We got to fill in the blank. So 5i squared root of 2 is your final answer. How would I write it so then it would just be a square root? So getting back. The 5 had to be a perfect square. So going the reverse order, you'd have to square 5, which is 25. And then you times it by 2. So this would be, I is the negative 1. You'd have 25 underneath, which would come out as the 5. And then times the 2 that's already underneath. If we multiply that together, it'll be a negative 50. All right, with number 18, trying to do that, we'd have to, underneath the square root, you have the I is negative 1. X to the 3rd, that was pairs. There were 3 pairs that could come out. So that'd be x to the 6th. There's another x left over here, so I'm going to put that right next to the 6. So we're going to multiply those together. We have a 10 from here. And then the 7. The 7 is going to be squared to go back inside, because that's the opposite of square root. So that's 7 squared is 49. And then this negative. The negative underneath the square root won't work because we already have this negative. That's going to be the I. So that negative actually stays on the outside. So it'll be a negative square root. 10 times 49 is 490. X to the 6th times x to the 1st is x to the 7th. And it'll be a negative because of the negative 1. And that should be the final answer. All right, number 19. We have biggest perfect square is 9. That is there. And then x squared, that can be simplified. So you have negative 4 times x times I times 3. And how many squares can you take out of, how many pairs can you take out of x squared? Is just 1. There's nothing left over underneath the square root, so the square root there is no longer there. It's gone. So you have negative 12. X times x is x squared I. 20. 400 is actually a perfect square. That's going to end up being 20 I. Final answer. 21, we have biggest perfect square that divides out of 90. Let's see here. We got the negative 1. I know 9 times 10. So square root of 90. So we got 90 divided by 4. No. 90 divided by 9. Yes. 90 divided by 16. No. 90 divided by 25. No. You can keep doing this. 90 divided by 36. No. 90 divided by 49. No. So 9 is the biggest. You can also look at it as, and if 9 is the biggest, this 10, you can't divide it by any of these perfect squares. 10 doesn't divide by 4, doesn't divide by 9, 16, 25. If it did, that means that that 9 would not be the biggest. There'd be a bigger one. All right, so we have the square root of 9 is 3. Square root of negative 1 is I. Square root of 10. So 3i square root of 10. All right, 22, we have a negative 1 on the outside. Negative 1 times, let's see here, 40 divides by 4. That's 10. 10 is not divisible by 4, 9, 16, so 4 is going to be your biggest. So that's going to be 4 and 10. So now we have negative 1 on the outside from the negative. Square root of 4 is 2. Square root of negative 1 is I, square root of 10. It's going to be a negative 2i square root of 10. And that is it for 3C. Hope this helped.